We are in section 7.2, and I wanted to hop through the section and do some examples. I know you have watched videos that the author has created. I also wanted to weave in some other thoughts because you've got to make this your own. You've got to see what's going on. It's got to make sense to you. And I want to show you a couple of other thoughts on a few of these examples. Before we get started, I do want to remind you of the little sticky note I had in my video in 7.1. You and your brain have to wrap around this, that if we are looking at, and I don't know how you and your brain want to do it, where you want to go with this, but I'll just start right here with the inverse sine. The inverse sine is going to be restricted to the first and fourth quadrants. And then we saw that inverse tangent, and I tied it in and said, that's what's in the numerator for tangent is sine. It's going to be in the first and fourth, restricted to the first and fourth quadrants. But wait, we've got some issue going on at the top and the bottom parts. And so let your brain kind of see that sine gets it all. Tangent gets it all except for the starting and ending points. And then there's one more, cosecant, because it's the reciprocal of sine. It gets to be over here too, but it misses out on this middle part, 0. So sine gets it all. Tangent gets it all except for the endpoints, and maybe that's not a pretty way to say it, but the starting and the ending numbers, the pi over 2 and the negative pi over 2. And then cosecant gets it all also, except it cannot be the 0. And so in your videos that you've been watching, you are learning about secant, cosecant, and cotangent. And on the bottom of 463 is when cosecant got added in. And cosecant can be between the negative pi over 2 and pi over 2 inclusive, but it just can't equal that middle one. So I'm just trying to give you some visual clues or cues or some things to just look on and think, okay, this is starting to make more sense with my sine getting it all, my tangent getting it all except the very ends, the pi over 2 and the negative pi over 2, and then cosecant, who goes with the sine, is getting it all except for this middle part, because then I can replicate that here. If I want to look at cosine, cosine gets it all. It gets all of the first and second quadrants. Now cotangent, because it's cosine over sine, that's the way I like to remember it, it's going to get it all too, except, just like tangent, it's going to get it all except for the endpoints. In other words, it can't be 0 or pi. It's everything else but not equal to those. So just like over here, tangent got it all except for the endpoints. Cotangent gets it all except for these endpoints. And then the other guy, secant, secant gets it all, including the endpoints, except for this middle piece. It can't have the pi over 2, which is exactly what happened over here. Sine gets it all, tangent gets everything except for the endpoints, and cosecant gets it all except for the middle piece. It replicates over here that cosine gets all the quadrants, 1 and 2, and then cotangent gets it all except for the 0 and pi, and then secant gets it all except for the middle piece. So having said that, I want us to look at a couple of examples. I'd like for us to do 1C first. And so as we're looking at 1C, you need to pay attention to the directions, because on our test, and that's not the best reason to pay attention to the directions, it's just always good to follow directions. But anytime it says, and this is example 1, part C, anytime it says exact value, you can just leave your calculator off to the side. But we're going to go find the exact value for the inverse of cotangent, which is a negative square root of 3. And so they're asking us to go find an angle so that, and I like to say it as this part in here was our old answer, and this is, they both still are, this was the answer, and this was, or is, the angle. Either way we want to do our grammar on this. But this is the answer. We're looking for the angle. In other words, cotangent of some angle turns out to be the negative square root of 3. This helps my brain to start thinking about that cotangent is x over y. Okay. If I can make this into two parts, then it would be x over y. Then I can look at it as a triangle. I know that if I'm dealing with cotangent, which is related to, I lost my paper. If I'm dealing with cotangent, it's related to my cosine, so that means I'm in quadrants 1 or 2. I'm going to go ahead and block my brain there that I'm in 1 or 2. And if I'm looking at a negative, it's not going to be quadrant 1, so my triangle, where I'm playing around with, is going to be over here in quadrant 2. With that being said, my negative can go in the numerator or the denominator. It just goes where I need it. And in this particular case, I need it for my x, that this would be the negative square root of 3, over my y, which is a 1. And at this point, you should be recognizing that this is going to be either a 30 or a 60-degree angle for theta. With it being a 1 and a square root of 3, the hypotenuse, the radius, is going to be a 2. Then you should also realize that it's not just any old theta. With a 1 being on that side, this is a 30-degree angle inside of there. But it's not an actual just 30-degree angle. I've got to use it as a reference angle, and then the angle I'm really looking for is 150 degrees. Having said that, we're doing everything in our inverses in radians. And so I've either got it memorized, or I'm going to do a quick conversion. My zeros divide out of 10. Let me divide out of 3. And I have 5 pi over 6. So this cotangent of 5 pi over 6 would generate this number. And a better way maybe to say it is that my angle, which is this, or what I'm even looking for, my inverse cotangent of negative square root of 3 is, well, we were looking for 5 pi over 6. Final answer. So I like showing this method where we're actually looking at the triangle, and we're also finding that angle in the triangle, and then blocking it down to its restricted quadrants. This is a good time to stop the video and go back and look at this. Are you liking this way better, his way better? Have you found something better on a website? But more to think about on how to figure out these inverses. So now I'm going to jump back to example 1a. So looking at example 1a. In example 1a wants us to find the inverse secant of 1. The inverse secant of positive 1, right? Positive 1. And so I get all excited because this made a whole lot of sense to me, so I'm going to do that again. And if we're talking about secant, secant's related to, it's the same thing, because secant's related to cosine, which is related to, so we're in quadrants 1, or we're in quadrant 2. And it's a positive 1, so I'm going to need to go ahead and do this. And I'm going to do what she did. She split it up and did a 1 over a, And so secant, I'm looking for this angle. What theta is the inverse secant of 1? In other words, the secant of what angle is going to turn out to be 1. Well, I can even play around with it a little bit more. I know that it's a 1 over 1. I know that I'm dealing with a cosine. I know my cosine was x over r, so this has got to be r over x. And wait a minute. r over x, that doesn't make sense that those sides would be the same. So this is great to use, but you got to realize when it's not going to land inside a quadrant, it's going to land on the axes. This one's a quadrantal. The ones, negative ones, and zeros need to be extremely suspicious that we're landing on a quadrant. So if that's the case, that means my secant was 1 over 1. When I do its reciprocal, that means my cosine is 1 over 1. So that means my cosine is 1. Where is my cosine? 1. Well, if I come right over here, that coordinate on the unit circle is going to be 1, 0. There's your x, there's your y. Here's the winner. So what we've been talking about, dancing around, do I do it this way? Do I do it this way? It didn't work on this one. But it helped me to realize it's quadrantal. Then what I'm looking for is that my inverse secant of 1 is going to be a 0. Having said that, you also need to learn how to check your answers. And to check our answers, we are supposed to be able to say that the secant of 0 is supposed to turn out to be 1. Or 1 divided by the cosine of 0 is supposed to turn out to be 1. And so when I go grab my calculator and turn my calculator on, and I do 1 divided by the cosine of, not decimal, I've got it on the side here, 1, look at it this way, divided by the cosine of 0, I get 1. Double checks are great, especially when you're getting ready to turn in your test, to go back and do a quick double check. I'm going to kind of keep going quickly. Remember, you can stop this video and you can play it back and let it pause, think, soak in whatever you'd like for it to do. But another question I'm wanting, or another example I'm wanting to do is 2b. No, or not 2b. And so down here at the very bottom, we see 2b. It's the cosecant inverse, so 2b. I'm going to do the inverse of cosecant, and it is a -4. The inverse of cosecant is -4. So we're looking for the angle. We're looking for the angle that when we do cosecant of that angle, we end up with an answer of -4. And I know he talked to you about punching in some of these numbers, and I'm asking you to do these numbers by yourself without looking at your notes very much. But looking at this one, another way to see it is, it would also be the same thing as looking for the theta, not of the not of the cosecant, but the sine, and not of -4, but of -1/4. Do notice in the directions. Notice in the directions we have to be in radians, and notice that they want us to round it to 2 decimal places. So when they say rounding, I'm not doing a cute little triangle like I did a while ago. But what I am going to do is realize that I'm talking about, I'm sorry about having this so out of focus or out of view. I am talking about cosecant, which is related to sine. And when I look at these, I have to remember that sine gets blocked to the 1st and 4th quadrants. And so does cosecant. It gets blocked there, but remember the little silly thing I was doing a while ago, it just can't have 0. But it can have everything else. And also to remember that we're talking radians. And so before I go any further on punching this into my calculator, remember that we're going from pi/2 to -pi/2. I'm going to go ahead and punch that in my calculator and get a decimal value. And it would be really good if you would go ahead and memorize this number, but you can still find it. Pi divided by 2 is 1.57. So I need to keep in mind that 1.57 radians is as high as I can go, and -1.57 radians as low as I can go. Any number that I get that turns up in between those two numbers is acceptable, and I am done. So here I go. Grabbing a calculator, I'm looking to do sine, missing some symbolism here, the inverse sine of this -1/4. So I can do that one on my calculator. I can do inverse sine of a -1/4 is 0.25. And then when I hit equal, I get a negative, oh, that's weird, 0.25. It said to 2 decimal places. So I'm going to jot down that I think my angle is about a -0.25. But I am not circling that. I am not turning this in as my answer until I do a quick verification. -0.25 is my answer for theta. -0.25 would be about-ish, right here-ish, and it's a winner. It is between my 1.57 and my -1.57, so I'll circle that one, and I'll keep going. But now I'd like to look at 2D. And when we look at 2D, it's down here at the bottom, and it says it wants us to do the inverse cotangent of -2. So we're looking for the angle, so that if we did cotangent of that angle, the answer that would pop out on the calculator would be -2. With that being said, I can also look for that angle not as the inverse cotangent, but as the inverse tangent, not as a -2, but as the reciprocal of that. Okay, then I'll grab my calculator, hit clear a bunch of times, make sure I'm in radians. I was in radians a while ago. That's a very good thing. And I'm going to do inverse tangent, and I'm looking at -0.5. So -0.5, and then I'm going to hit equals, and I get all excited because my theta is going to approximately be a -0.46. Woohoo! I got me an answer. I'm going to circle it and go on. And no, I'm not. So I'm going to go back over here and think for just a second. So when I go over here and think, I'm now dealing with cotangent. Cotangent deals with cosine, and that means I get blocked 2, 1, and 2, the first and second quadrants. Okay, so if it's a cotangent of a negative, I'm not able to just block to 1 and 2. I got to get blocked over here where this is my theta. Okay, I'm in radians, so there's my 0. We found out a while ago that's 1.57. Really don't care right now on this one, but I do care that pi is about-ish 3.14-ish. So my answer that I just got, by golly, better be between 0 and 3.14. Woohoo! I got a -0.46. I cannot turn that in as my answer. It is not in an appropriate quadrant for doing an inverse cotangent. But what it is going to have an angle, a reference angle, that I can do now. If that was a 4.6, this is going to be a 4.6. This is a pi. I can take pi, subtract the angle that I've found, the one I've calculated. Boy, that's a nice not straight line. And then that's going to give me the theta that I need. So I grab my calculator, and I could do 3.14. I can do, and I could have left that number on there. And this is where our approximations are going to possibly vary if we don't nail down some rules. And so it's going to depend on what MyLab Math wants, whatever the book wants. I'm going to go ahead and do this. I'm going to go ahead and punch pi, and I'm going to tell it to take off this little piece of angle, this 0.46, and I'm going to hit enter. And when I do, the angle I'm getting is about 2.68. And now I need to think about that. It's 2.68 between 0 and 3.14, and so this is looking much better, that the inverse cotangent of -2 is about 2.68. You know, I think I want to check this one. So what I'm going to do is I'm going to say the cotangent of 2.68. What does it turn out to be? It better turn out to be -2. But to do cotangent, I've got to do 1 over tangent of 2.68. And again, by golly, it better come out to be a -2. So I've got my 1, clear. 1 divided by tangent of 2.68, and I'm still in radians, and I think I punched in some good stuff. And when I hit equals, I get -2-ish. And that's going to be based on rounding. I probably should have left my 0.46 in the calculator to make it a better number. And so when it comes down to the test, one thing you need to know is that I will return your test with a short answer key. And any question that I've counted wrong, you can always send a picture back and argue. And any points you get are gold. So don't say, oh, it's just 1 point. Always talk to me about what you got on your test. So there's one more question that I want to do. Again, this might be a really good time to pause, think on this. You've seen other ways to do this, and I'm playing around with the way I like to do it. So example 3. Example 3 is the last one I want to look at, and example 3 is on page 465. And I love, love, love these. Right here, you see it says, we are supposed to find the exact value of the sine of the inverse tangent of 1/2. I can't see it. I love these. And so what I do is I have to think quadrants, non-restricted, or where I can be, the non-restricted. And then I think triangles, and I think working inward and outward. If you were in class with me, I'd be patting my belly right now. We're going to start in the gut, and we're going to work our way out. And so having said that, I need to go over here and look for some angle whose answer was 1/2. The inverse tangent is 1/2. So I need to go look for that angle. Okay, let's think for a second. Tangent. Tangent is related to sine. Tangent and sine get restricted to the first and fourth quadrants. This is a positive. That means it's going to be up here because it's going to have a y over x that are positive over positive. If it was negative, it would be down here in the fourth quadrant. Tangent. Tangent is y over x. If it's y over x, it's y over x. Y over x. If I know that it's a 30, 60, 90, 45, whatever, then I can go ahead and throw that down. If it doesn't make any sense to me what my r could be, then I am going to go ahead and calculate it. My r is worth the square root of my y squared plus my x squared. My r is worth the square root of 1 plus 4, or my r is a square root of 5. Now that I've calculated all parts of my triangle for this unknown theta, I don't have to know theta, I just need to know its parts. Once I have conquered this inner part, I am done with this inner part, and it has provided me theta. So now I'm literally going to back my way out and say, well, then what's the sine of that theta? Well, glad you asked. So here we go. The sine of the inverse tangent of 1/2. What is the sine of this over here? It is opposite over adjacent. Oh, can't leave it like that. Got to rationalize, and so we're getting square root of 5 over 5. I love, love, love these examples, but I'm going to leave the last two for you. So I wanted to jump in, do a couple of these examples, pause, go back and look at, send me questions, but definitely take time to let these soak in our section of 7.2.